All right, welcome to the session on completable futures, the promises of Java. My name is Venkat Subramaniam. We're going to talk about, first of all, a little bit about what are completable futures, why we really need them. And then we'll talk a little bit about how it's implemented in Java, how we can use it. And along the way, I'll also compare and contrast this to something else that we have in Java, which is the Streams API as well. So let's get started. Well, one of the first things I want to start with is some lessons that we can learn from JavaScript. I know that sounds really odd, but it's true. We can actually learn from JavaScript as well. So JavaScript has gone through a phenomenal growth over the past several decades. And one of the things that JavaScript programmers have learned real the hard way is callbacks. In fact, they have a special name for it. It's called the callback hell. If you ever think callbacks are a good idea, I have a suggestion for you. Walk up close to a JavaScript programmer and utter the word callback and watch them begin to cry unconsolably, because this is how really painful it is to use callbacks. Well, the JavaScript world has moved on to use promises. So what is really a promise? A promise is an object that would have one of three different states. It may be in a state which is called a resolved state when it has completed. It could be in a rejected state where it has said that, I don't have a good result, an error condition, or it's in a pending state. So it's going to be in one of these three states, but if it's in a pending state, it could potentially resolve or reject, but if it's in a reject or resolve state, it would never ever change after that. A promise itself has two channels of communication. This is the data channel through which data would come through, an error channel through which an error would come through, but it would be one or the other, and you treat failure like it's data. And one of the really nice things about promises is it's really easy to compose promises, and that's one of the nice things about it. Let's just spend a minute on this to understand how this is going to work. So when you have a promise, let's say you have a promise, well, a promise contains actually two tracks, so to say. You can say there is a right track or a left track or a top track and a bottom track, depending on how you want to say it. And you have these two tracks, and you have these tracks filled with functions. So suppose a promise yields a data. Let's say this is a data we got, and you pass this data through a function, and if this function is successful, you get another data from it. And that will go to another function. If that were successful, you'll get another data. But instead of a data, something goes wrong over here, then immediately this function would route you through the bottom track, or the left track if you want to call it that way, with an error. Now when you have this error over here, you can pass that to yet another function. If that function tried to restore sanity, but it couldn't, it blows up again, well, you have another error, and then this could continue for a while where you're going to be in this error track. But let's suppose you call another function and the function is able to recover from this error. Well, then you suddenly jump over to the track over here, and the next function potentially could be returning data for you. So this is an example of how things progress through promises. So on the left, you have a function that gave you a promise, and that generated a piece of data, and you pass it through another function that generated another piece of data. That passes through another function. That failed for whatever reason. You have an error, and then the next function also blows up, and you are always in this blowing up stage. And then this says, I can handle it. Now you're back over here, and then you're able to continue on the good track. So this is an example of how promises propagate data and error through them. And of course, this could go back and forth. This is just one example. Potentially, you may have just branched off right here, and you could be dealing with data here. So you could be going across the tracks anytime you want to. So think about it as these two tracks, and everything is going well. You're on the right track. Something goes wrong. You're on the left track. Something keeps going wrong. You're on the left track. Suddenly, something is better. You're back on the right track, and you could be zigzagging your way through. And that's basically how the data propagates through these promises chain in the case of JavaScript. Now, I know what you're thinking is, we thought we were coming for a Java-based session. Why are you talking about JavaScript? Well, here's the beauty. JavaScript has promises, and when I started looking at completable futures in Java, I was very intrigued and confused. I was thinking, what in the world it is? And honestly, it took me a little bit of time to figure out that completable futures in Java are absolutely nothing but promises in JavaScript. If they had called it promises, everyone will understand it. So they said, no, we'll give a completely different name so nobody would have a clue. So completable futures really are JavaScript promises. That's why I called it the title as the promises of Java, because that's what completable futures really are. So completable future in Java is really a sample of promises in JavaScript. You have what are called stages. So what's a stage? A stage really is, you could say this is a stage. A stage is a segment of the pipeline where you're performing some action, a function, and then you go to the next stage and the next stage and the next stage, and you have this completable future full of these stages. Let's understand this with a little example. Once a stage completes, you are ready to run the next stage, and it can keep moving. Let's look at some examples of this. Let's create a completable future and play with it. This is going to be somewhat of a trivial example to begin with, but let's give it a try and see how this is going to work. So what I'm going to do here is to create a function, and this is going to be completable future. That's what I want to return from here. So completable future of integer type, we'll call that one. So this is going to be an integer type of completable future, and I'm going to call this as create for now. So we'll start with baby steps. So what do I want to do here? I'm going to say this is going to be a completable future, obviously, so completable future. And in this case, of course, I'm going to create an example, so return a completable future of, let's say, a sync over here. And what am I going to provide as a response in this particular case? So I will go ahead and say that when you call this one, this is going to simply return the response of a compute method. So nothing really exciting at this point. Let's go ahead and write this method called compute. It's going to simply return some response right here. We'll just return a 2 to begin with. Again, nothing really exciting at this point. That's what we are starting with. So this is a completable future we want to start with as an example right here. So what am I going to do here? So we'll go ahead and start with a little completable future object. And what I want to do is to start running these calls through this async future and run through it. Let's go ahead and take a look at this real quick, what the method name here is. So we'll say this is going to be completable future object, and that's going to be the class. This was introduced as part of Java 8, and this is the funny part. Java 8 introduced both streams and completable future. A lot of us got excited about streams, and we kind of didn't really pay much attention to completable futures, but this is something really exciting that we have available in here. So if you look at the static methods this contains, there is a method here called supply async. That's what I'm really trying to call right here, and we'll call the supply async, and you can see that it takes a supplier which doesn't take any arguments really, and that's what I want to go ahead and call the supply async and run that code. So what is this going to really do at this point? Well, this is going to be really trivial, but we'll get started with this. I'll call the create method, and then I'm going to say then accept, and we'll put sense to these methods in just a little bit. I'm going to take some data given to me, and I want to just print out this data that's given to us. So we'll start with this little baby steps right in here. So all I'm going to do is call this create method that we created right here and invoke the create method and ask it to perform this operation. And of course, that's going to be a static method as well. I'm in the static context, and it printed that beautiful 2 as a response. But what does it really do for us? To understand this, let's go ahead and ask the question right in here. Output, let's say, in main, of course, and we will ask it for the thread that's executing this particular code, and I'm going to say thread.current thread, and you can see that in this case, this is going to be obviously the main thread of execution, no surprise over there. But the question is, what thread is going to execute the compute method? So if you look at the compute method right here and ask for the current thread, you will notice that that's automatically in the fork join pool, common pool thread. So when you create a completable future, as you did on line number 11, it is executing the compute method in an asynchronous manner in a completely different thread. Now, obvious question we have right now is, where does the print execute? And this is where the fun part really is. So to understand this, let's go ahead and take this and call it as a printed, where I'll create a separate method right here called printed, and the printed method takes a value, and it's going to simply display the value right now. So when I run this, you can see the 2 being displayed, but out of curiosity, I want to know where the printed method is actually executing. So if I say printed colon, and then say thread.current thread over here, and run this code, therein it's going to display the thread of execution, and what does it tell us as the thread that's executing it? So notice the printed ran in the common pool thread as well. So why is that? The word I want you to think about is the word non-blocking. So in other words, in asynchronous processing, you want to be in a non-blocking situation. Suppose you ask for a cup of coffee from somebody and they say, I'll make it to you in a minute. Obviously, you don't want to wait for the coffee. You want to go do other stuff. And when the coffee is ready, they could give it to you. So the idea is you want to be in a non-blocking mode. So when I ran this code, you noticed that in this particular case, it ran that piece of code in the common pool thread, but don't assume that is the case all the time. Why not? Because the reason is, it is quite possible that by the time you are coming to execute this, the thread may already be completed, and the main might as well execute it. And that is another beauty of this particular approach, is the threads can be really different. To illustrate the point, let's go ahead and create a completable future right in here is equal to, and we'll just assign what create gives us to that for a minute. Let's go ahead and sleep here for just about a second, if you will, and then I'm going to call this completable future, and then I'm going to ask it to go ahead and consume the data that it is returning for us. And then I will go ahead and say, sleep for another second, so we can just display the result after this. So what's going to happen at this point? Well, in this particular example, what it really did is that it's going to take this completable future, and we have fired it off, and it's executing in the background. Then we take our sweet time, take a little siesta, come back and call the then accept at this point, and ask it to execute that code at this moment. So when I execute this code, what does it really do? Notice the surprise over there. The print it now ran in the main thread, not in the pool. Why is that? This should make really good sense, because this thread was executed, it finished its work. There is no reason for the thread to waste its effort and wait for you, and you took your time, and now you came and connected to it. Remember, this completable future is in the pending state at this point, and then of course it could resolve or it could reject it. Well, by the time you got to that highlighted piece of code, the completable future is no longer pending, it is resolved. So because it's resolved, it immediately ran on the main thread. You don't have to block for a result that's already ready. So the point about non-blocking is not to create a thread. The point about non-blocking is not to block. So if the result is already there, why bother creating another thread? Might as well execute it. So it's pretty darn efficient, as you can see. So these things happen for you pretty nicely behind the scenes. So you saw the thread of execution and how that works really nicely. You can also change the pool in which this is executing. So as you saw here, when you ran this code, the things that you saw here were running literally in this common pool thread, which is nice, and I like common pool thread, but there are times when you don't want to run things in a common pool thread. You may want to run in your own custom pool after all. So what do you do if that's what you really want to do? So to understand that at that point, let's come back to this example. Notice again, the common pool thread is what you're seeing right there. But what I'm going to do in this example is, again, don't take this example literally, but I'm going to create a fork join pool right here. So I'm going to say fork join pool, and I will just say FJP here is equal to new fork join pool of 10. Let's go ahead and say I'm creating a fork join pool. Now when I create this in the supply async as a second argument, I can provide the fork join pool that I want to use, and you can see now it's no longer running in the common pool, it's running in the custom pool we just created. So that's how easily you can tell it where to run it. By default, it uses the fork join pool, but a common pool, on the other hand, if you provide a different pool, it uses that particular pool, as you can see. So that gives us an idea about how this is all working. Now let's talk a little bit about the methods we are looking at. Well, we know that Java 8 has the idea of streams, and we have completable futures. Most of us in this room, I would assume, are fairly familiar with Streams API. So what are the things you use in Stream? You use for each in Stream, which takes a consumer, if you remember, right? And then, of course, you also have a map, which takes a function. You also have a filter. Well, that takes a predicate. Let's not worry about it for now. now. So these are the functions you normally use in the streams API. A for each uses a consumer, a map uses a function. If you remember what the method of the consumer is, the method of the consumer is called accept, isn't it? Just keep that in mind. What is the method of function you recollect? That is called apply. Just keep that in mind as well. So these are the concepts you're familiar with in streams. And when I started playing with completable futures, I was a little bit confused because, I would like these transformations to happen, but why are these methods looking a little different and a little weird? And there's a reason for it. Now, before we go any further with this, let's understand this with a little bit more example right here. We call the compute method right in here. We call the printed method right in here. We created a completable future, as you can see, right in here as well. And then let's go over here to use this one in this particular thing. We'll just go ahead and say, and we will accept it and print it. Notice the result of this was a value of 2. So what did the then accept do? It really printed the data for us. So you can kind of get the picture now. So this is equivalent to then accept. So just like your for each method of the stream API, you have a then accept in the case of completable future. And now you know why they called it then accept, because it is going to be a consumer. So because you're passing a consumer to it, they decided to call it as then accept. You may wonder, why didn't they just call it for each? The reason for it is the stream may have a 0, 1, or more data. On the other hand, a completable future can at most have 1 data or error, right? So this is basically one of the key differences between the two, is that a completable future can have at most 1 data or error. On the other hand, a stream can have as many data as you want. It's going to be a stream of data coming through. So it doesn't make sense to use the word for each, because there's only one. What does it mean to say each in that context? So that is why they called it then accept. So you can see that it's going to accept a consumer as well. So that makes really good sense. Except for one small difference. When you're taking a stream and calling a for each, remember a for each is a void method. It doesn't return anything to you. It's end of story. There is something weird about completable future. Okay, this is the irony. A completable future never completes. So this is like Thor in the movie. You're going to see Thor again. Thanos in the movie, right? The bad villain. You're done with this Avengers, but Thanos is back again in the next one. So it's kind of like that. It never ends. So just to illustrate the point, notice I go here and say, then run. Well, why run? Because I don't have any more data. So all I'm going to do is simply do a run, and this is going to take a runnable. And now what am I going to do here? I'm going to say all done. So when I run this code, you will notice that it says all done. But the beauty of this is you can say then run, and then you can say output right here, and then you can simply say not really, right? So you can keep going with this how much ever you want to go with this, and it'll keep on going. Now, one thing I challenge you never to do is wait for this to be over, because that is never going to be over. So keep on going, right? So there is absolutely no end to it, and that is one of the ironies of completable future. So it's kind of like a train. You get onto the train, and when you want to get off, you do get off. Never ask the question, where does this train go? Because that's going to be a long route. So a completable future is a pipeline. You can get on the pipeline, you can exit when you want to, and I know what you're thinking. You're thinking, I wonder where that completable future is going. Well, just don't worry about it, right? Because it's never going to finish. It's going to keep on going. So that's an example of completable future. You can just keep through this pipeline, and you can keep executing it. So what you can do here is you can do some operations with the data, but then you can do some logging with the data. And you can say, you know what, I send the data to the database, and you can do a logging. So then run can be very useful for that purpose. So you can provide that very nicely. So that's an example of how you can draw this nice pipeline. So we saw then accept, but one of the things you do in the case of a stream API often, so I talked about then run already. One of the things you can do in the streams API is you can perform a nice map operation. Remember what the map does? It performs the transformation of data. Well, it's quite clear we want to transform the data. The map function will transform 0, 1, or more pieces of data, but here I want to just transform one piece of data. That's all I want to do. So how do I really do that? Well, that's where then apply comes in. And notice the word apply from here. So that should really make sense because we are performing a transformation. We want to provide a function to it. And that's why this is called then apply. So you can see how that kind of nicely matches that call. And we can use the then apply function. Let's give it a try. How does the then apply really look like? So I'm going to go over here and say dot then apply, and given the data, I want to take the data and times 2. Remember, we've been returning a value of 2. 2 times 2 is 4, and as a result, of course, we're going to display a value of 4 in the end, and that's where the transformation of the data happens. So if you were to subscribe to an asynchronous service, maybe this is a web server that's going to give you a stock price, and you have registered with the stock price service and said, give me the stock price when you have it. And then you're not blocking. When the stock price arrives to you, you can take the price of the stock and you can do stuff with it. Maybe you want to take the price and discount it, or maybe you want to add a surcharge to it, which is more likely than what you normally do. And then you want to then perform operation with it and maybe send it off to another service for transactions. You can do that pretty nicely, as you can see. So that is an example of how you can go through this transformation, and so the then apply can happen. Similarly, you can also do a then apply one more time, and you can take the data right now and you can perform data plus 1. Obviously, these could be 2 different methods you are interested in using. So 2 times 2 is 4, 4 plus 1 is 5, and you can see the result of 5 being displayed right there. So that's a series of transformations you can apply to the data that you get from the completable future, and so that nicely flows through, as you can see. This really helped me to comprehend what I'm doing because these names really didn't really connect to me in the beginning. So as I started really looking through them, I said, why are these called then apply and then accept? So hopefully the reason I gave you is a little bit easier to keep that in mind. There's a really good reason for these names to have these things like then apply and then accept end of that. But obviously, we are looking at a pipeline of operations that we are performing, and you can see the pipeline that we created right now. So that works really well. But on the other hand, let's go ahead and take a look at one slightly different example. What if we want to create a pipeline and then come back and deal with propagating the data? This is a little bit of an unfair example here because in this example, as you can see, I just created the data at the source. That is not very realistic. So what are we going to do? Let's go ahead and take a look at a slightly different example to see how this would work. So I'm going to go ahead and say over here, completable future one more time. But this time, I'm going to create a method called process. So the process method takes a completable future, and this completable future, we'll just still keep it as integer, if you will, and this is going to be a future I'm going to pass to this particular function. We'll come back to that function in just a minute. So now I'm going to say completable future of integer. We'll go ahead and say a future is equal to new completable future. Notice I created an empty future object right in here. Then I pass it to the process method and ask it to do some processing with it. Well, the process method is going to form the pipeline for us. So notice what I'll do here. I'll take the future given to us, and I'll say then apply, and given a piece of data, I want to take the data and multiply it with 2. Then I say then accept, and I'm going to simply take the data, and I'm going to just print it out. System.out println, and we will just print it. As you can see in here, this is going to just form the pipeline. That's all we did. Once you form the pipeline, you can take the future, and you can say complete, and you can pass the data that you want to pass to it. and based on what you really want to do, you can pass it to this. So I said complete, isn't it? So you can ask it to complete it. So notice how this is going to work. Somebody could give you a completable future. You could draw up a pipeline of that future and be ready for it. And in this case, you can say, given this particular data, whenever the data arrives, I will take the data and double it. I'll take the data and increment the data afterwards. And then, of course, when the data is pushed through the pipeline, I can then process it and print it. Again, I want you to think about this in the scenario of a remote call or an asynchronous call. You might send a request to a web server and say, give me the stock price for Google, and then you could set up a little pipeline as to what to do when the data for Google arrives, stock price for Google arrives, and you can pass it through a pipeline at that point. So this is an example of how this is all going to work. So that seems really reasonable so far. But I know what you're thinking. You're thinking, wait, but you never talked about things going wrong yet, and in real life, things always go wrong. So how do you deal with it? I do have to admit, this is not something I'm too happy with. I'm not happy with the name they gave for this at all. But before we talk about the name they gave for it, let's talk about how to really handle it. Remember what I showed you in here, this pipeline. Up to this point in this presentation, unfortunately, I only showed you the happy path. All I showed you was the then and then and then and then. But what if things were to go wrong? What are you going to do about it? Well, this is where the unhappy path needs to come in. So what I'm going to do here is I'll go to the future. And you could do this at any point you want. And here's the name that I'm not happy with at all. It is called exceptionally. And this is really a sad way to say it, right? This is actually not exceptional at all, right? But I think they had a very dry sense of humor. So they called it exceptionally, right? And then what do you do here? In this case, you get a throwable, and before we implement the throwable, I want you to closely take a look at what we did here. If the function that's dealing with exception gave you another exception, you stay on the unhappy path, which means this function either blows up or this function quietly returns a result to you. That is something you have to be very careful about. You cannot write an exceptionally function and return a data because then you're signaling, I'm okay, I handled it. So if you want to say this is really broken, you got to blow up one more time. So notice what I'm going to do here. I'm going to take this exceptionally, and I'm going to go ahead and say over here, I'm going to then say a handle, that's what I'm going to call it right here. I'll call it as handle. And I'm going to pass the throwable all the way to that particular handle function. What does the handle function do? So in this case, the public static, let's say in this case, integer, so int, and handle, and this takes a throwable, if you will, so throwable, and let's go ahead and say throwable. And what am I going to do within this throwable? I'll first of all print an error right here, and then I'll print out the throwable. Then what am I going to do? I'm going to quietly return 100. So that means I recovered from this problem, and if I found an exception, maybe I will substitute another value for it, right? So you are saying, this particular example, the way I have it right now, you had a problem, you come in here to this with the error, and this guy says, I took care of it, and bounces you right back to the happy path. That's what I'm doing at the moment. But of course the question is, how do you signal the error? How do you tell something really went wrong? So let's first of all run this code real quick. Notice it still gave us a value of 5, and the reason is you completed with the 2. So what happened when you completed with the 2? When you completed with the 2, the future resolved with the 2, so you step over the exceptionally and arrive at the then apply. I know this is a little hard to see this, but you got to kind of put a pair of glasses where it gets easier when you get old like me, because it's already I can see 2 lines here. But the point really is that for the young people, you have to squint your eyes to see it. So this is the top line, and this is the bottom line, right? So in this case, the exceptionally is right in here, and the thens are right in here. So if everything went fine, you're going to kind of hop over that, right? You're not going to get into the exceptionally, and then you're going to get to the then apply, and you're going to take that path. So if you're thinking, if that is true, can I have exceptionally over here? That will be absolutely exceptional code to have that as well. You can put as many of them as you want to. So you can have these series of things filled up anywhere you want to. So when I run this code, notice it was successful. It bypassed the exceptionally, came to the then apply, and then except. So we passed a 2. So it bypassed this, and 2 times 2 is 4, 4 plus 1 is 5, so it printed 5. But I want to say that something really went wrong. How do I do that? Well, if I want to say that something really went wrong, this is even better name in my opinion. They really were playing with this. So you can say future dot completed exceptionally, right? So this is even better, isn't it? So here, the reason I like this method really is, I'll tell you in a second. So what am I going to do? New runtime exception, and I'm going to simply say something went wrong, right? That's always very useful. So we'll say something went wrong and give that error message. So this is going to blow up with a runtime exception called something went wrong. So when I run this code, what is it going to really do? Well, in this case, it's complaining, so complete exception, not completed exceptionally, complete exceptionally. And notice it says error, something went wrong, but then the result is 201. Why is it 201? Look at the line, well, let's look at the line number. Look at line number 12. Line number 12 printed that message, and remember what handle exception does. It returns 100. So the next line says 100 times 2 is 200, 200 plus 1 is 201, and that finished. The reason I love this message is, as programmers, when you start programming completable futures, this is only programmers will know. So when the boss comes around and says, how are things going? You simply tell the boss, I am completing it exceptionally, right? So they, and the rest of the programmers know what you're talking about. This is our secret communication from now on, right? You can just wink to your developer, I complete exceptionally. So this is a nice way to communicate. So you're saying it pretty much, foobarred on that particular point. So the whole idea behind this is that you are just passing through this exception and saying, handle this. But what do I do if I really want to blow this up? Well, at that point, I'm going to come down here, and rather than returning 100, I'm going to simply throw new runtime exception and say, this is beyond any repair, right? So I can blow this up even more, and notice now it does not display 201. Why is that? Because this completed exceptionally, so it dragged into this exceptionally block, that blew up one more time, and because you blew it up, it will not come to any of the then block, and because there is no exceptionally after this, it simply exit at this point. So in other words, what we have right now is that we started up here, and we had an error right in the beginning. We came to this bottom track, and we stayed on the bottom track, never to go up, because we had no recovery from this particular exception at this point. So that is basically an example of how you are able to deal with these two really nicely. So that gives you an idea about how we can deal with exceptions and chaining. So this is all working really well. Except in Java 8, there is one huge deficiency. And the deficiency is that when you start a completable future, I want you to go back to this example for a minute here, and notice in this example, if I compute this with a successful case, and when I run this code, notice it printed a value of 5. So that worked really well. On the other hand, if I blew it up and run this code, you can see it printed that something went wrong. But what if for some reason I never get the data from the server? And what's going to happen when I run this code, and notice it does not do anything? So this could lead to a situation of a live lock, isn't it? So what's a live lock? Live lock is where you're waiting for an event that will never happen. So this, before I answer what to do with it, I want to talk about a philosophy of life. And I'm going to say in life and programming, don't do anything. Usually I can just stop with this actually, but I'll continue. So in life and programming, don't do anything without timeout. This is a very important rule to follow, right? Now I'll give you an example. I always tell young people about this. If you're trying to find a perfect love, wisdom, even trust me on this one, you want to look for a perfect love, but time out on it. Otherwise, there's a chance that we will die alone, very old. So this is something really good. I mean, this is built into the Indian culture, just to emphasize this. This is why we have arranged marriage. So the parents tell us, go find the love, but if you don't, you're going to marry whom we tell you to do. I think that's pretty wise. So the point really is that it gives you a little time out to deal with, right? So you always, I'm just kidding, but only a little bit. So the point really is that you want to always perform a timeout on things. Well, sad part is in Java 8, they did not have timeout, which means you just don't know how long you're going to wait for something to finish, and that's simply not acceptable. Well, I'm using Java 11 over here, but they fixed it really quickly in Java 9. So in Java 9, you have a timeout available. Let's think about how timeout will work in this scenario. So notice I have a complete over here, but I'm going to call this process, but I'm going to sleep for about 2 seconds of the time. Let's say 3 seconds I'm going to sleep for it. Then in the end, I'm going to sleep for, let's about say 5 seconds. It's going to be a little slow, but that's okay. And then eventually, I'm going to, say that this is completed. Let's go ahead and say, here's a sleep function. Let's go ahead and run this. When I run this code, what does it really do? So in this case, of course, after a 3-second delay, I'm going to complete it. And as a result, you will notice that it's going to display the value of 5, obviously. That's what you would expect it. If you don't mind, I'll run this on the command prompt. It's a little bit easier to see this on the command prompt. So we'll go ahead and go to the place where I have this code, and then we'll run it on the command prompt. So let me get rid of this so you can actually see this a little bit better. So what I want to show you here is just how this code is going to behave with the timeout, with the sleep, and see how this is going to work. So let's go ahead and fire this up. I'm going to just run this code right in here, and you can see that at the end of the 3-second delay, you got the data output as you would expect. Well, that worked really well. On the other hand, if I were to blow up after the time, clearly this is going to blow up, shouldn't be any surprise also. So you can see that's working also, and you can see the error message appear after that delay. But on the other hand, what if I don't do anything at all? Well, unfortunately, in this case, we're going to just keep waiting, and when eventually the program finishes, or if it's going to run for a very long time, nothing exciting happens, unfortunately, and so as a result, that's not acceptable. So what are we going to do to fix it? So what we're going to do to fix it is, let's put the complete again, but as soon as I create the completable future, I'm going to say future dot, and I'm going to say complete on timeout. And I'm going to say, give a value of 500, and then I'm going to give it, let's give it about 3 seconds. So I'm going to give it about a 3-second delay, and let's make this a 2 seconds of delay. So at the end of 3 seconds, so let's go ahead and say 3 time unit dot seconds. So this says complete on timeout with a value of 500 after a delay of 3 seconds. How does this really work? You have told this future, you have a window of 3 seconds. If you finish within the 3 seconds, we are good. Because remember, once a completable future resolves, it'll never change its state. So once it has resolved in the time, if you come to resolve it again, that will be discarded, and so as a result, that will become a no-op. On the other hand, if you took more than 3 seconds and you have not still completed, then this is going to complete with the value of 500 and say, here you go, take it. Let's make sure that's actually true. Let's run this code a 2-second delay later. We got a value of 5 as you would expect, and the reason for that is we completed successfully. On the other hand, if I fail after 2 seconds, you will expect the exception to appear, because once it rejects, it's not going to change its state. That's working as well. On the other hand, if I don't complete and if I don't blow up within the duration of time, then what is it going to do? I'm going to send a 500 through this pipeline. 500 times 2 is 1,000 plus 1 is 1,001. Let's see if that's what it's going to do. So 3 seconds has expired, and now you can see 1001. That's because you didn't finish in the time allocated. It's going to go off and finish it for you. Now, obvious question is, what's going to happen to the task that you started? What if it eventually comes back? Well, sorry, we don't care about it. So that's going to be asynchronous, and we don't wait for it. We keep moving at this point and do whatever that we need to do. So that is an example of completing on timeout. But what if you don't want to complete? What if you want to blow up if something really were to go wrong? Then rather than doing it this way, simply say future.rTimeout. And in this case, I'm going to give an allowance of 3 seconds. And notice that now you're saying, if you finish in 3 seconds, I'm happy with you. If you're not finishing in 3 seconds, if you didn't blow up in 3 seconds, I'm going to destroy this thing for you. So once again, let's go ahead and complete it for ourselves. Go ahead and run the code. In this case, what does it do? Oh, let's go ahead and fix this right here. So our timeout. So this is going to be time unit dot seconds. There's an exception right there in my code. Let's try this again. So this is going to give us, can't find the symbol, our timeout. So this is going to be, okay, let's try this one more time. So this is going to provide the value for us. So right there, and you can see that it actually completed. On the other hand, if I were to blow up within the duration of time, it is going to give me my blow up, which is called something went wrong. And you can see it says something went wrong. On the other hand, if I don't complete, if I don't blow up, then it's going to time out an error at that point. So once again, let's go ahead and run this and see that. And 3 seconds goes by, and it blows up with a timeout exception to tell us, sorry that I waited this long, you didn't finish it, I'm going to blow up at this point and call it as quits. So what's the moral of the story? Never use completable futures without using a timeout. It depends on your business domain. Sometimes it makes sense to go ahead and complete with the result. Sometimes it makes sense to blow up. Who can say other than you what the right thing to do in your situation is, but it gives you the option to pick and choose what may make sense in your scenario, in your application. So we saw those two, but then I want to talk about 2 other functions in the next 4 minutes and talk about what those things provide for us. One of them is called a combine method. And this really made it hard for me because I was trying to understand what a combine really means. So to understand this, let's take a slightly different example and play with it. So I'm going to go ahead and say over here, let's go ahead and create a completable future. So we'll say completable future right here. And this completable future of integer says create. And what it's going to do is, it's a silly example, we'll pass an n over here. And all it's going to do for us is simply return. So we'll say return completable future dot supply async, and it's going to simply return this value of n given to it, right? So nothing really exciting. So we'll start with that little step for now and see where it takes us. So what I want to do now is to call this method create, but the way I'm going to do this is I'm going to say create with a 2. But there are times when you might want to combine the results of 2 asynchronous operations. For example, a request comes into your server and you need to go get the current balance for the customer, but you also want to know the credit limit they are eligible for. So what would you do? You got 2 calls to make. Why bother? You could do them at the same time. You can send one request asynchronously to say, get me the current balance, another request asynchronously to say, get me the credit limit. When both of them arrive, you can continue forward with your operation. So in other words, what I want to do is combine. So what do I do to combine it? So what I'm going to do is to take this completable future that you have here, and I'm going to say then combine. And what am I going to combine it with? The create over here of 3. So I'm asking it to combine with the 2. Now, when you combine it, what it's going to do is take these values and put that together. So as I was looking through this, I asked myself, tell me something that I'm used to already. And and that you know what it is over here. It's the reduce method. So the reduce combines things for you in a stream API, isn't it? So this is very much like reduce, and this is called then combine over here. So the then combine will mix the result of two asynchronous operation. One goes off, the other goes off. When the first arrives, it waits for the second to arrive, and when both of them are ready, it can merge them through for you. That's basically the purpose of this then combine. Let's see how we can use this right in here. So I'm going to say then combine, and then I'm going to say, let's call it as A comma B, and then I want to just mix them together, A plus B over here. And what is this going to do? It's going to give us another completable future. So then I can say then accept, and then of course system.out over here, and this is going to be printing the result of both of those. I know this is a very silly example, but hopefully this illustrates what this is doing. So this is going to get us a value of 2, this gets a value of 3, 2 plus 3 is 5, and that's what we are expecting this to do, and notice how that got combined into the result. Now obviously if one takes longer than the other one, this will patiently wait for that to come through, and of course you can use a timeout on that as well if you really wanted to. So hopefully that gives you an idea about how we can use combine. So combine is kind of like a zip operation, right? You're taking two things and you're merging them together. In this case it's a reduce that you're bringing in. That's why this is a binary operation you're performing right in here. Well, that's great so far, but then let's talk about compose. But before we talk about compose, we have to talk about something else. So before we talk about this, we got to talk something else. What is that? So that is, when you look at a streams API, I want you to think about something for a minute. If I have a one-to-one function, meaning I got wonderful people in this room and everyone has a first name. So for every person, I want their first name. That's a one-to-one operation. So if you have a stream of P and you perform a map of F1, where it's a one-to-one function, what is the result of this? It's a stream of R. We know this, right? On the other hand, if I have a one-to-many function, like I want all your email addresses, and that way I can spam every one of them. So in that case, I want a one-to-many mapping. Then what do? Well, stream of P of map of F one-to-many, one-to-n, will return, unfortunately, a stream of a list of R or something like that, which is not very much fun at all if you think about it, isn't it? So what do I do if I really wanted just one list and not a list of lists? What can I do? Well, then what you do is you take the stream and you perform what's called a flat map. And a flat map is going to take this function, but the result is going to be a stream of R. So this is the time when you would decide whether to use a map or a flat map. If you have a one-to-one function, use a map. If you have a one-to-many function, you might want to use a flat map rather than using a map, because a map will give you a stream of a list of R or a stream of R, whatever that may be, whereas this is going to give you a stream of R. Well, where I'm going with this is, we know that we have a flat map in this case. Well, same way, if you really think about it, this is where the then compose really comes in. So what does a then compose do? Then compose gives you an ability to take a result that returns a completable future and return back from that. So that's basically the idea is, if you want to perform an operation which will in turn give you a completable future, thank you, I'm told it's a timeout. So you basically what you can do in this case is, should I stop talking? All right, so just bear with me for a minute. So what you can do here is, you can, just 1 minute. So what we can do here is, you can take the completable future and you can return a completable future in return for it. And this is where the then combine really compose really comes in. So in other words, you take the result you got here and simply say data, and you call maybe a create again, if you will. Notice this itself is a completable future that you're getting. And in this case, of course, you'll use a compose, and that is the whole idea, because when this is returning a completable future, you want the result of this is not a completable future of completable future, but a completable future of the data itself. With that, I complete this. Thanks for your time.